for
Recording
when
is
we're
on.
rendering uh, the results. So whenever I hit enter over here, it should show something like a yellow. It changes color and it shows the loading results. So this is why we're using this over here, just to show the state. And this is for checking time. And these are for just sending debug messages. And this is the index that we just loaded from the lib file. Uh, so yeah, this is what this looks like. This is the default implementation for it. And we also have a reset function. So what a reset function is instead of exiting from our uh, UI to make another search, we can just do this and it can reset. So that's what this is here for. And we got a bunch of debug messages for whatever purpose that we want to use. Let's say we can just use the debug messages. So yeah. So right here, what we do is in the main, we load the index first. We get a time for to see how much time it took to actually load the index instead of building the index in the compile file. To load the index, I think it takes right about like around 8 seconds. So yeah, that's something we could probably optimize if we use threads. Uh, and we can set up the terminal and run the app later on in right here. So what this does is it enables the row mode for the terminal. So enabling row mode means you don't like the terminal will stop seeing things like usually when we use the terminal in our shell, it has things like it checks for things like new lines and stuff like that. And when we're enabling row mode, we're just disabling all of that features that the terminal has. Then we're just entering to our alternate screen. We're using a backend. It uses a backend system that it uses this to send the debug message and a bunch of other stuff as well. And when we exit from our TUI, we use this function. So we disable the row mode and we show the cursor as well. So in the run up terminal, what we're doing is we're drawing the UI after we enable the row mode. And the UI itself is a function we could go to. So what the UI does is it creates these little widgets. All of these boxes you see are widgets, and it just creates those. So for the type block, you see it has a title that says search type, prefix, and it also gives it a color so that when we are at that specific uh, input, we could just uh, know what we're at, and we could just use the state to track which input we're using. And yeah, so that's what this does. And it also handles we're using the trover over here. This okay, so uh, this is for the turn block. Then there's the for the main block, which is the main area. We have defined it right here. We use the trover if the app loading is true, which is the boolean from the struct, and we just render out our outputs. And right here what we're defining is let's say if we're doing a suffix search like this, uh, we we're just using this to you see how we have a special coloring so that it's to show where in the suffix we found it. So let's say if we have a line and if we have a suffix the and contains the, I just use this to show, hey, this is actually a contains and it's a valid output. So yeah, so better show this. We could just
Yeah, that's pretty nice. Yeah. And it shows okay. I know about this crate, but I never actually used it. I just read a few times about it and used some tools that are using it. But yeah, it's a very nice crate. Can you still hear me?
Uh, if you can, yes, yes, I can hear
I just hear you very slowly. You changed something, or it's from mine?
you. Okay. You can see it, right?
Now it's fine. I can also see it and hear you. Okay.
Okay. So that's what I defined right here. When we are hovering over it, we just use the light yellow, and that's what this does. This is just to make the outputs look prettier. Uh, but in retrospect, I think it would have been better if I used if I used a CLI, because that's what everybody does. I think that's the standard way to do things. I was just always interested in building a EGUI or a UI, a TUI, so that's why I made this choice.
No, I think it's very nice, and it's also a good learning experience. Uh, the classical CLI, the advantage of it is that you can then build a UI whatever you want, like a actual GUI application or a browser or whatever, or integrate it in a
Yeah,
pipeline easier. You know, if it's like that,
yeah,
because
yeah,
if it's already having the UI, okay, you are, let's say, stuck with that. But what you could also do is like create it like an API, your entry point, let's say, function and stuff that interacts with your code, and then you can have two implementation, one with the TUI and the other with the classical CLI. And actually, those are just a thin wrapper that just actually calls your function that does the magic, you know. So then that stays the same, and then you can again, the advantage of this is then you can also, so other than building application calling it as a CLI, the advantage is
yeah,
that you can use it as a library in other crates, for example. Others can use it yours as a library, and actually it's like idiom, Rust idiom, and a good practice to actually develop your
yeah,
code, even if you do a CLI application or a UI application, or if it's the end application, develop it as a library, and then so all this starts from the lib file, and then use it in your main like you like the application, because then you are actually the user of your library. So then it's very easy to test when you distribute this as a library. So you actually use it like other developers are using it yours. You know, so you can keep it up to
yeah,
uh, keep it updated. You can also feel the other developer experience. So you can do better code with this actually. You can increase the
yeah,
other developers experience actually.
yeah, yeah, yeah. That's what I noticed. Everyone uses CLI, and it also makes it easier to build other application on top of the CLI instead of
Yeah.
UI like this.
Yeah, and the advantage with the pipeline is also no noticeable. I mean, you can integrate it in, I don't know, Git, CI/CD, you know, something like that.
Yeah, 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 yeah. In retrospect, I think that it would have been a better decision to use that instead of this, because I would have learned like famous crates like Clap,
Mhm.
and it would have made it easier learning experience.
I think
Nevertheless,
I think this is also a very good learning experience, and it's not hard to, let's say, migrate to that, you know, and have that and have
yeah,
them in parallel, like I said.
yeah, yeah, yeah. Yeah. Oh,
Because
okay.
maybe you've
So
worked, or but it's quite simple to work with Clap, very intuitive. I mean,
yeah,
simpler than doing the TUI.
yeah, yeah, definitely. Oh, like building this tree was probably the most frustrating part. Partly because I used ChatGPT,
Mhm.
and using ChatGPT or any AI on Rust is an unthinkable thing to do.
Why you say that?
I would never do it again.
Why?
Oh man, even like for the most basic things, it's so frustrating. It is so frustrating. It's so draining. I always like end up using an AI to do some like mundane task that I don't want to do in Rust, and I always end up like regretting it. I will say, man, I could have done this faster. What? Why did I use this? No.
Well, I think depends on the situation. For example, I use Copilot, which is integrated in the IDE, and for like you
Yeah.
say, mundane tasks like I don't know boilerplate code, and it's for me it's actually quite good. And what I like is it analyzes your project code and it makes suggestion based on your code. So you can suggest calling a function that you have in your project that's not from an example on what it learned somehow. So it
Yeah.
I
Yeah.
mean your project becomes the the system prompt. I mean, if you're familiar, so the context. Your project becomes the context on which it operates, so then you can make suggestions based on the actual code.
Yeah. On your based on your other code. Yeah.
Mhm.
Uh,
Yeah,
Almost
but
everyone I've talked to, even I went on the Rust Discord, and even a bunch of my friends told me if you want to learn something, like never use Copilot or anything, never use that. And
uh,
only for the explicit purpose of like debugging code that you know, or
well,
maybe just writing like boilerplate.
well, depends. I mean, for example, uh, I use it when I prepared for algorithmical data structure interviews, for example, because
Yeah,
if I were to let's say learn a new algorithm and data structure from scratch, I'll need to read like a few articles on the web, then I don't know find
yeah,
some sample code, learn about that, write that, and then I don't know find some problems with this algorithm. So it takes some time, to do this. And the nice part with ChatGPT was that I told him I wanted this, and actually it synthesizes the information very good. So it actually gives you in the end, at least for this kind of task, what you will spend. I don't know,
yeah,
maybe 30 minutes. He can give you like in a prompt, actually. So you can have it
yeah, yeah,
just reading about it, and you then continue with the examples and stuff like that. I agree with the code is not always so close to useful, and yeah, sometimes it hallucinates and it creates method that doesn't exist, and yeah, sometimes it can go sideways a lot. But if you combine it with reading, I mean, using the book to read to have some ideas of what's possible, and asking it to generate some parts, and also what's useful, also for the example that I gave before, but also when it generates code, it explains the code. So you can actually
yeah,
learn. You can learn from that part. You can actually learn because it creates some methods, it creates some parts of the code, and then it takes parts of it and it explains quite in detail
yeah,
how we got
yeah,
to that. So it for that I think it's good to learn. But yeah, you should not rely
yeah,
so much on it. So you should. I am trying to use it responsibly. So let's say so I'm trying to use it
yeah,
like a tool as much as it's useful. I'm not relying 100% on it for sure, and I'm not using it, for
yeah,
example, for quite abstract code, quite let's say more complex code. It's not good. So like generating a function is fine, but generating a full flow, I never had a good experience with it.
yeah, yeah. That's going to be a headache.
Yeah.
Yeah,
So
yeah. But
it
you're definitely right. When I was like even studying the data structures, like for example, for the Ngram, the on the wiki there was no pseudocode, and I just had to use like ChatGPT for it to like explain it to me. And I was also for this project, I was strictly trying not to use any AI because I feel like uh, I should be able to just go here and understand these maths and just build it myself. Of course, for this specific instance, I just use a crate
Mhm.
for Leverstein, but I feel like for any other things, let's say, like the other day, I was trying to just see this Mandelbrot algorithm. And after this project, right now, it's like before this project, I would have never been able to just go here, understand, and just write code.
Mhm.
But right now, after this, I can see, I can read, I can understand it, and I could just write a code for a Mandelbrot renderer.
Yeah,
and stuff like that. So
that's very nice. Yeah. Just that, so
yeah,
if you really want to learn and understand the algorithm, I agree, yeah, that it makes sense to also read about it and implement it yourself. But there are cases, for example, when you just want something quick. I mean, you have other to
yeah,
implement and you just need the
yeah, yeah,
functionality quick, like, I don't know, for example, having a number uh, written down. So how 259, so to write these words
yeah,
259. So you spend a lot of time. I don't know if you ever implemented. I implemented this from scratch at some point. So there are a lot of corner cases, let's say, with 111. I mean, also in Romanian, for example. In English, maybe it's a bit easier, but also in English, there are. It's not a very clear rule that you just generate. There are corner cases when you need to pay attention to the combination of digits, and you spend quite a lot of time. And
yeah,
maybe this is not so important for your project. You have other goals and other more complicated stuff to implement. So then it's reasonable to ask ChatGPT to generate a function like this. And yeah, in time when you want to understand that algorithm and stuff, yeah, it makes sense to stay and understand it and write in your own. Yeah. But for doing
yeah,
something
yeah. I
quick,
definitely
it's a good
understand.
tool.
Yeah, yeah. It's like I just wanted to get this hard skill first before I want to transition to using it. Of course, I still use it, and especially what I noticed in the Rust community is like using AI is kind of a taboo, and like when you ask different devs, they have their own approaches as to how they use AI when using Rust. Some of them say, "Hey, I only use it for like debugging purposes." Besides for that, I write everything on my own. And some of them, like you, they say, for boiler code and stuff like that. But I always end up regretting it and stuff. So,
Well, how
I always try to, you know, build the skill first, then find a method that works for me when using ChatGPT,
I know, just that
you know.
the problem is, let's say nowadays, other than let's say when I started programming, like, I don't know, 22 years ago, uh, there are different expectations, so somehow,
Yeah,
as the technology evolves and the algorithm evolves, so actually there are more stuff to learn now than before. There are new algorithms, new stuff, which we didn't have back then. And if you were just to learn, everything of that, and then start to, I don't know, to develop something, it takes a lot of time. Actually, like this, there is actually a normal point when your lifetime it's not enough to learn as much as, I mean, we already passed that point, but I mean, you spend way more time, just learning what exists. That's why these kind of tools are like shortcuts, which of course are not offering the same, let's say, quality standard that you understand the code and stuff, but we need to do more now than back then. So actually we
yeah,
need, we need to create
yeah,
more functionality, more everything than back then. And uh, the AI is like, I don't know, when the internet appeared, or I don't know, when industrialization appeared and machines and stuff like that. It's here to stay. It will not go away for sure. So it's like exactly like internet, Google and stuff. I was skeptical at the beginning also. Then I realized that uh, if you're using it responsibly, uh, then it's a useful tool. But you need to understand it's not smart. Let's say, okay,
yeah,
now these ones with reasoning models are a little bit different story, because they tend to have, let's say, smartness characteristic and glimpse of smartness. Let's say, but they are not there like a human mind. But most likely they will be, and very soon. I mean, sooner than I think anybody expects, because just looking retrospectively year to year, the evolution is exponentially, but we are way far from the beginning of the exponential function. Because I mean, even if you look at the graph of exponentials, at the beginning, visually you see it increasing slowly, but then it explodes. And I think we are way far from the beginning of that. So year by year, we see scary, let's say, a bit evolutions. So I'm just
yeah,
I'm just
yeah,
trying to to cope up with this, or to embrace it, but in a reasonable way. I'm not there to, okay, you need to use, because there are people like this. I'm far from that. You need to use AI. Everything they do with AI. It's bullshit, and then you end up generating a lot of bullshit content, and then the next version of the AI will learn and train on this bullshit content generated by previous version of AI. So you end up with making it stupider. You you don't make it
yeah,
smarter like this. So you need to use it for what it's okay. I mean, I don't agree with facts. I don't even like to. There are people who respond emails with ChatGPT and stuff like that, or write emails. Or I'm really against
yeah,
that. For example, so even more if it's a technical email that I need to write about what I have technical expertise, they want my opinion. They don't want. They could look it on ChatGPT if they wanted ChatGPT opinion, no. So they want my opinion. So I think it's only reasonable
yeah,
to give them my opinion and not transform in what AI thinks. Okay, I
yeah,
I
yeah,
sometimes I sometimes use, for example, there is a Grammarly, like it uses AI to suggest you better I mean, to rephrase your sentences in a better wording.
yeah,
Let's say I use that when I need to respond, like, I don't know, a CEO, a CTO, a non-technical person,
yeah,
because I don't have
yeah,
a very good non-technical language. I'm okay technically, but I don't have
yeah,
that jargon or what they speak. So then it helps me speaking their language. Let's say, but I always
yeah,
write the email first by myself, and then I use it to enhance it. I don't tell it to generate it for me. So I never do that. I
yeah,
think it's actually unprofessional.
yeah, yeah. Definitely, that's how I use ChatGPT for writing emails as well. Sometimes, like, I feel like my English isn't good enough, or I just feel like sometimes I can't express myself very well. So in those instances, I use it. But aside from that, I think it's a very big taboo, especially to use it on blog posts and stuff like that. And there are also people that can notice when you're using an AI. So yeah, I try to not use it as much as possible, only when I need like grammatical correction or stuff like that. Um, but yeah, I'm definitely on with you on that part. Um, yeah, okay. Um, so yeah, so here we just draw the UI and we set if it's true, we just use our throbber, the one that shows the loading animation. Then right here, what we do is we're getting the results and the duration it took to get the results in order to, like, for example, here, let's say I'm doing a search like this, so that I could later use it for the debug, so that I could use how much time it took and I could print out the results. And right here, we could edit what our keystrokes do. So right here, Control C, I with C and Control modifier, it would exit. By default, it would just be pressing C. So I just did this, and the escape button we use to reset it like this, and we get a message. Um, so right here, it's when we press down and up, that's the one we use to see the the specific one. You see when we press down and up, so that's to update the state right here. And yeah, um, so page up and page down right here. This is for the debug one to scroll up the debug window. So yeah, that's what is defined right here. Uh, so we saw the UI function, and right here the other functions that we use are the handle, because I think we called them right here. So for scope input, we have the handle scope, we have the handle input, we have these functions. So the handle scope is just we either enter one or two. If we enter one, we say that, hey, okay, the scope we're selecting is the words, and we pass that off. And if we're using handle input, if it's either one, two, or three, that means we're selecting this specific one. And yeah, that's what we're doing. And for term input, it is after we press enter on the term input that we get the results. So when handling the term input, we will also do our search right here. So what happens is after we enter our term, we get a debug message searching for the item, the term specific right here. And we also get these are like the app sender, and these are things that we use to send the debug messages. Then right here we get the clones. Sorry, we get the indexes, and afterwards we just start a timer right here so that we could see how long it took to make the specific search. So right here, it says, yeah, it took this. Wait a second, let's try to load it again. Uh, so it should print out, yeah, the time as well. So that's why we're using this over here, and we just decided to use a thread right here just to make it faster when performing search. So that's what we're doing over here as well. We are calling the perform search function in here as well. And if we press C, it overrides, by default, is used to quit it. But if we press C, it just pushes C into the input term. And this is the backspace. So yeah, this is how the app works. And here for line search, we can, okay, I think a better way to solve line searches would be to uh, load, there's this one, I have this. So the outputs one, this is the one. Of course, it's little amounts of words, but yeah, we should be able to see what. Uh, okay, that was fast. Okay, so yeah, so yeah, this is how we use it. Uh, it's not as fast as I would like it to be. Uh, yeah, it takes quite a while, especially even for this uh, small data set that only has, I think this has about 4,000 lines and 19,000 words in this one. It's okay. This we could switch to the other one because I think we were saying that we should handle millions of words efficiently. So let's go here and yeah. So uh, for this one, it's still handles it in the mid 100 milliseconds. Uh, I created a benchmark for this as well, but the benchmark, I'll show you there's a problem with the benchmark, and I think that's because it caches the results it gets. And okay, so for this, let's say I'm searching AN. Mhm. So this is half a million words. So for this, it's 13 milliseconds. Uh, yeah, I'm definitely not satisfied with this result. I feel like I could get everything, every result into the microseconds. I tested out 10TV as well, and like for I tested it out for the word the. So every line that contains the word the, I think I finished it in the 400. Yeah, so it was twice as fast as this when I used 10TV, and not twice. It was actually millisecond, not millisecond, but microsecond. So oh, yeah, that's way faster than this. Um, so yeah, but as for optimizations, I was planning to do it another time. So after I got good at Rust, or after like have a better knowledge about threads and stuff like that. So yeah, uh, yeah, but this is pretty unsatisfying results. So yeah, sorry.
No, I think it's very good what you did, and it's yeah, optimization of a later for sure.
Yeah, yeah. It would be perfect if I could get things into the microseconds for every circumstance. Then I would be happy. But I guess optimizing code is a bit tough because I tried it on other projects and um, yeah, I'm not good at it right now.
Yeah, that takes time, and yeah, the more experience you have,
Yeah,
the easier it gets. But it takes time also to just do the optimization till you find where the not not so good spots are.
yeah. So yeah, I mean, so like for a starting place, yeah, I did this. This is how I did the search engine. Uh, and yeah, so what do you think about it?
I think it's really good what you did, and yeah, I told you, over the presentation my comments what I felt need to
Yeah,
intervene, but yeah, I think you did very good, and it's a very good standards
yeah,
what you did.
yeah, yeah. Thanks for the vote of confidence.
Yeah, it's a very good job.
Yeah, yeah.
What experience did you had with other languages? Or your,
With other languages,
yeah, I don't
uh,
know.
uh, okay. To be honest, I practically don't have that much experience. Because uh, well, I used to like coding back in the day when I started with C, and those were the good days because I was like struggling to get past like the first or the second page on the documentation, and then I got into an issue where I could not uh, use my computer anymore. So that means I could not code. In that period, I kind of hated coding or hated programming because it was something that I loved and that I wanted to do at that point in time. It was something that I was thinking about 24/7, and it was such a good experience. And not having that experience just made me hate it. So throughout college years, I didn't do much coding. Uh, I mean, I could do the basic like web pages. Um, of course, nowadays TypeScript I could do with AI, and that's like AI could do it for me. But as far as having like really nice experience with programming languages, like Rust is probably the only one I've gone and ended up
And
like
C,
to this extent.
how much you did C? Just a bit
C++,
psychology.
I was like 70 pages in on the documentation. So like 70 or 60 pages. I thought I knew what C++ was back then. And it was only 70 pages, and it makes me laugh right now in retrospect. But
Yeah, but it helped
so
you
I didn't even
learning
finish.
Rust, no? I mean the concepts at least, and you see the advantages of Rust over C.
Oh, yes, yes. Uh, yeah, partly why I took so long when studying the documentation was because I want to understand how uh, how the people that created Rust intended things to be. Especially, I want to see how the compiler handled things and what's the advantage related to other languages. I was reading a lot about that as well. Yeah, I mean, aside from the usual yeah, uh, they allocate after freeing and the usual memory safety that Rust provides. I'm sure that it has also other advantages. Uh, I was also reading on, I think on one of your blogs, you were mentioning how Rust handles state very cleanly related to other languages. Uh,
Oh,
yeah.
which one? State pattern. I mean,
Uh, oh man, I think you wrote a lot of blogs. I don't even remember which one it was. I think it was an interview
yeah, but
blog.
what about what's the topic? I didn't quite
Uh,
understand what you said.
I think uh, you were you were talking about how you got into Rust, and
Ah,
you were
yeah,
saying
yeah,
what interested you was the fact that it handles states so cleanly. I think you saw it from a YouTube video a friend sent you. That's what you said on the blog.
yeah. It's
And
state pattern. Yeah, so there is this state pattern that it's
yeah,
like a design pattern, and it's differently. I mean, the how it is defined
yeah,
there is differently how on how Rust, let's say, implemented it. And
yeah,
yeah, it was, I don't know, pretty
yeah,
clear for me that if they pay, if because the let's say the differences are subtle between those, but are very important actually. It's at the core. I mean, everything with Rust is so subtle and stuff, and then yeah, well,
yeah,
I was sure that I will find other nice things like that, and yeah, there are a lot.
yeah, exactly. Yeah, that's why I was taking like a lot of time. I could just go ahead and read through this, but I want to understand every nuances of the programming language. And yeah, I feel like that's where the magic of Rust is at for most part. It's in these little tiny details of how they implemented this and how does the Rust compiler work. Even understanding that is going to give you like a better perspective for when you want to, let's say, write optimized code or stuff like that. And I like Rust. I feel like when I read Rust, I'm teleported into the future and I don't have to deal with a lot of problems that other programming languages deal with. And yeah, the, uh, so yeah, I try to go into the inner workings of Rust. I also check out their repository as well, uh, just to see how they implemented some features in the standard library or in the core library, and it gives me like a better understanding. Uh, yeah, that and also in the future, I want to make my own parser. If possible, I want to make a compiler, like a small little compiler. I was seeing, uh, you know, some person I met online. He did his own little small compiler in Rust, and I definitely want to do that.
Yeah, I think that's very
Maybe,
interesting. It's a beast by itself. I mean, it's pretty different than other type of,
yeah,
let's say, programming.
yeah, yeah. This guy did this. He did, and he was telling me. I was telling him I want to build a parser, an interpreter, and a compiler. Because and he told me, you know what? Why not just build a compiler? Because it's like that's the progress you would go down. And he's right. Uh, this is the compiler he wrote.
Yeah, I think
Definitely use this.
you learn a lot doing this.
Yeah, yeah. So like right now when I study Rust, I try to see, hey, what's happening in the compiler, or hey, what part of the compilation or step is optimizing the code, or stuff like that, so that someday I can build my own like this. I mean, this guy he did it too good. Maybe not as optimal as this one, but it works, and maybe that would be enough. You
Yeah, that's very nice. Yeah,
know? Yeah.
nice.
Uh,
But
so that's that.
what you're doing now? You're working now in some.
Right now, I am working. I have a job. Um, I'm a front end developer, like with TypeScript, and Yeah, that's what I do right now. Right now, I'm doing tests, and sometimes I also build features. But for most part, I'm doing the tests right now. That's one of the places I work. And yeah, on another project, I also build some features. So
Mm.
yeah,
But you are friend with Job Schiffer
yeah,
or how's Schiffer? Your friend,
yeah,
your
yeah,
friends.
yeah,
You also are in Ethiopia, where are you located?
yeah, yeah. Io was actually the one who introduced me to Rust because he saw it and he was telling me, man, there's this really nice language. It was like almost a year ago, he told me, and then I didn't like hold it consistently. I didn't try to learn consistently. But right now, once I'm like learning it, it's really nice. Uh, and yeah, uh, I mean, part of me wants to rush and finish this and be like, oh, yeah, I'm done. But another part of me just wants to keep learning. And yeah, this is this is awesome. I also read some books. I don't know if you've ever read this book. There's this famous YouTuber,
Uh,
John.
I know it, but I haven't. And
Yeah,
it's what was the approach? Is somehow similar to the book, or it goes other ways? I mean, compared
yeah.
to the
This book.
to the Rust book, I mean, the site that
Yeah,
you have, it's similar somehow.
yeah. This book is after you already know about Rust.
Mhm.
You can just come here and it tells you about idiomatic designs. And I also see you talk sometimes about idiomatic ways to do things in Rust, and that's definitely something that comes with experience. So
Yeah.
I feel like books like these helped me, and I have a bunch of materials that I definitely want to go through before I say I'm even like kind of decent in Rust, like this book. And yeah, if you know this, Rust in Action, this is a recommendation that you also gave me.
Mhm.
Yeah, so here you just build stuff like uh, what was the objective? Here you build, but yeah, this is a good entry book into like actually implementing stuff in Rust. Like they build HTTP servers, NTP clients, and these are like really nice concepts. Uh, yeah,
Mhm. You still participate to the course, right? Because we took like a break now, but last calls
yeah,
you are in the course.
yeah, yeah,
Yeah, we need
yeah.
to
The Rust course helps a lot. Yeah,
we need to resume that because we the plan was also to have to build like a project from scratch for the whole evolution for the whole duration of the course, so then apply topics that are learned in the course. So actually, we want to build them like a mini Redis.
yeah, yeah. I was definitely planning doing that somewhere after like I mean my guess is I wouldn't need to know how to uh code unsafe for building a Redis. So I was planning if I reach somewhere around this part or yeah, I wouldn't need to go into unsafe. I was planning to build the Redis right around when I reach right here.
Yeah, I don't think you need don't need to save. And also, it's like even how we will, I mean, how we were planning to do is doing it simple, and then as we evolve in the book, then dividing parts like you did. So you didn't use threads, and you use threads and stuff like that. And I
Yeah,
don't know, not handling so good errors at the beginning, but then add better error handling and stuff like that. Because
yeah, yeah,
somehow this is the normal evolution of a project, especially if it's a learning project. Yeah, but I
yeah,
think you really have good Rust skills. So if you just spend that time that you said,
Oh my God, that's
very
such an overstatement. Uh,
no, I mean by
then,
the code that you wrote, it's very good. Of course, concepts can be learned and improvements can always be made. But it's a good code.
yeah, yeah. I mean, thank you a lot. Yeah, but I feel like I have a lot of things to learn. Even when I picked up this project for the text search engine, I thought, hey, it's only searching, that's the functionality necessary. But no, had I picked it up after like I read about threads and stuff like that, I would have known that no, that's a really big part about search engines and uh, even systems as a whole. And yeah, I mean, it's a learning process, so I can't expect to be perfect at it just from where I start off. But
That's not
yeah, I feel like I have a lot more to
the
learn.
life. The life would be boring, if we if we would do perfectly from the beginning. Then what? What do we do after that?
Yeah,
How do we evolve? Then
yeah,
it's boring.
yeah, yeah, yeah,
It's
definitely.
very good
Yeah,
that life is like that actually,
yeah,
and we learn by mistakes. So there is also this concept of fail again, but fail better. Actually,
yeah,
failure it's a very good thing actually that we have in this world. Because if you don't
yeah,
experience failure, you either not doing complicated. I mean, most likely you're not doing complicated enough stuff. You're doing something too easy if you don't experience failure. And it's very good to
yeah,
experience failure so that you learn how to recover from it. That's actually the most important because
yeah,
at some point you will experience it. And if you don't know how to recover, then it's tricky also for I don't know for a leader because he doesn't know how you will behave. So, I mean, for example, as a senior developer, the expectation from you is that uh, no matter how the situation complicates, they could rely on you that you, in the end, will find ways to solve it. I mean, ask more requirements, ask the right people, learn more, do research, and not trial and error, but you will solve it. They could just give the task to you, and you will do whatever needed to solve it. Okay, this is not expected from a junior programmer, but
yeah,
because it's normal. But the idea is that if you haven't experienced failure, and if you have a task like this and you experience failure, if you are unpredictable, I mean, if you never experience it, then it could be unpredictable your behavior, how you will recover from it. So
yeah,
then no more you respect that expectancy from them. So
yeah,
you are capable of handling things by your own. You know, so
yeah,
it's good for
yeah,
everybody to for everybody involved. It's good if you experience
yeah.
failure and learn how to recover from it.
Yeah. Part of it's like when I read a book, I right now for from the perspective from where I'm at, when I read a book, it's like I just accept it as truth and I just use it. I just follow it down to a T. Let's say if I'm reading a book on how to structure microservices or stuff like that, it's something like a book is like something that's sacred to me right now because I don't have that much experience. But like a year or two down the line, which is a crazy thing, I might not meet, not might not, but probably will not meet that goal. But I want to strive to be in a place where I'm not just reading books and I'm just taking them as a rule of thumb, but I'm like, I can read a book and I can say, you know what, this opinion I don't agree with. And I just want to be in a position where I could have enough knowledge to where I could like give opinions on someone who's writing a book. Maybe if I'm not able to write a book myself.
Hmm.
I just want to build, I just want to be in a place where I can have my own opinions and not be in a place where uh, I read a book and I just consider it sacred or that knowledge is something that I have to follow down to a T. No, so it's like a midterm goal that I'm like going to strive for. Uh, yeah,
Yeah, that's
yeah,
that's very good. And yeah,
yeah. Uh,
you're not far from it. I think you already have could emit different opinions, which which are good.
Oh, oh man, I wish.
Because anyway, there are no, let's say, you you also see there are different ways of resolving a problem. There are different kind of algorithms, so there is not the best solution, let's say. And
Yeah,
as the problem becomes more complex, let's say, not necessarily complicated, but complex, so it involves many parties or I don't know many aspects that you need in concepts. There are various ways you could combine those and find a recipe that even individually the solutions, let's say, are not perfect, but combined could offer the best result
yeah, 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 exactly. Yeah.
because
Um,
they could I don't know somehow uh, some parts failure could be I don't know recovered by others performance somehow.
yeah, yeah. I was also like speaking with Eyob the other day, and he was telling me that part of like being a senior dev is the your ability to foresee failures and to account for them when you're like working on that specific product. And yeah, I feel like that's something that just comes from experience. And it's like if you're not going to fail, you're not going to learn.
There is a meme in that regard. It says that a senior programmer failed more times than the junior tried.
Yeah,
I mean, try to do something. So, and there is another one that, like a guru, or let's say, a top level programmer, did all the possible mistakes, and anything that's left for him to do is only good things. So even if he does randomly from what it left, it's left doing, it's only good things. It failed
yeah,
everything.
yeah, yeah,
Okay, that's the part of learning from mistake. That's the part of fail better. Because it's good to fail,
yeah,
but you need to
yeah,
fail better. Learn and try different ways. Let's say not necessarily it will be the best ways or the good way, but if you do it differently, you have a chance to approach to a better solution. Let's say.
yeah, yeah, yeah. So, yeah, I was planning just to increase the volume of failures, and uh, I mean not volume alone, uh, also learning. But yeah, like I
Yeah,
feel like increasing the volume
is
gets you
there is also I don't know if it makes sense, but there is also the quality of failure. Let's say, so
yeah,
it's nice if you have good I mean, quality failures, from which you learn a lot.
yeah, yeah, yeah. Yeah, that makes sense.
Yeah. Okay. Ideally, you would prefer smaller failures. Let's say more smaller ones that you can easily manage. Because if it's a big failure, yeah, then it's harder to manage. But for sure, you can have a lot to learn from a big failure.
Yeah, yeah,
Well, it was a pleasure
yeah,
having this call, and
yeah,
yeah, I really think you will be great. And it's
yeah. Likewise, this this helps a lot. Um, yeah, um, yeah. Thank you a lot.
yeah, you're welcome, and the merit is yours. So I'm glad if I could help you, but yeah, the merit is yours. And I think this could be a useful learning experience for others too. So
Yeah,
yeah, I hope
yeah,
others will,
yeah,
will watch this implementation and learn from it.
yeah, yeah. Oh, yeah, definitely. I would also like if your friend finishes the a search engine, and if I could just go over and check it out on the GitHub or something,
Yeah, the plan is
would be nice.
actually I don't know if I sent you, but I'll send you now. The plan is also to uh, get all of these coding challenges in a common repo. So then everyone, let's say, or anybody could access those and I don't use it as a learning material and stuff. So I'll send you the
Mm.
details. So it will be great if you can push your code in there, and he could do it. Also, actually, it was his idea that it will be nice to gather
Yeah.
all these, and yeah, then definitely you could give it a try to what he did. Also, it just that it's in. I told you, I think it's in Java, but it's. I mean, for sure you can understand Java if you understand Rust so much because you don't have
Mm.
Java experience, right? You haven't worked with Java.
Uh, no, but
Yeah, but
I
it's
mean, it should be easy to relate, right?
yeah, because it's like let's say Java, it's like they evolve it from C. Let's say, I mean, it tried to resolve some of the problems that they had in C, like I mean, in C you can do, let's say, the same things various ways, and in Java they somehow try to standardize it and unify it, and somehow also Rust does this. At least for me,
Yeah.
it was like before I learned Rust, I I thought and I was feeling that programming is like language agnostic. I mean, if you know the data structure algorithm, if you have the taste of it and the thinking and concepts and so on, the language is just a matter of taste in the end. So uh, whichever you feel best, it represents your thoughts. But I mean, you could easily write it in any language, let's say. But when I learned Rust, I struggled a bit with okay, borrowing lifetimes and stuff, and because I was thinking how to implement it in how I knew in Java, but then after I understood how and I mean why and how the compilers allows me to do things, I understood that it's somehow the better way and than what
Yeah.
I know in Java. So it somehow makes you write better code and it guides you to the, let's say, better implementation. There was an article comparing Rust with Go, and they say at the end that Go makes your life easy, and but Rust makes you understand how things work. I mean, co- compute things, how things work, and make you write better code. And actually, I think it does. It does that. Even if it's a bit verbose sometimes, maybe it's better to have it's expressive at least, so you can clearly see what is happening. Doesn't do so much behind the scenes like Go. So yeah, I think it's a helpful language.
Yeah. 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 When you say Go, you reminded me. Go has a garbage collector, right?
Yes,
Uh, uh, I was just thinking, how hard would it be to like make a garbage collector?
to implement a garbage collector,
Yeah.
not easy. And I mean, i- the if you want to make it to the efficiency that I don't know are these days, I don't think it's easy.
Oh, yeah. Not to the efficiencies
I mean,
that are these days, but
I mean,
just to understand.
if you were to just understand the basics, okay, I don't think it's easy, but I think it's easier than a compiler. Compiler, I think, is
Okay.
more
Okay.
complicated.
Yeah. Okay. Uh,
I mean,
yeah.
but
Because I was
maybe
interested
maybe
in.
it will be a nice challenge. Maybe it will be a nice, yeah, task
Yeah.
for these coding challenges to do a very basic garbage collector. Actually,
Yeah.
so that's a
Because I was interested in. I was like asking other people apparently because like in Rust when we store a stack allocated memory and a heap allocated memory, I noticed that when we store these two types of data on the memory, there's a middle area in the memory which is totally empty. And I thought maybe that was the Rust compilers doing. And apparently they told me that's how memory is handled in that's like the system architecture behavior.
yeah.
Then ever since then I was just
It
interested in like.
it's in any language is handled like this. So the idea is that uh,
Yeah,
if you were to do it the other way around, I mean, put the 100, I don't know, something megabytes or something for stack and the other for heap, let's say, what happens if you need in your runtime a little bit more stack than those uh, I mean, let's say if your stack goes beyond 100 megabytes, but the heap is empty, so it's an inefficient way of using memory because you will need to move the other way around, then you will have partitioning, then you have gaps, you have the fragmentation. It's complicated. So if you start at one end at one end, the other at the other end, when they meet, your memory is full. But otherwise, they can use as much as is free. So depending
yeah,
on which one uses more, they can use from this available space. So it's like just imagining is like between us there is an available space, and any of us could use as much as possible. It's not a limit. It's not a fixed limit. So it's a very simple algorithm. Let's say
yeah,
if you use it like this,
yeah,
that's why everybody's using
yeah,
is doing like this because then any can be bigger. The sum is limited. That's all. So the sum is
yeah,
the fixed size, but the actual values is variable. It can vary.
yeah. Well, what I was very interested about was for stack allocated, it grows from high memory address to low memory address, and for heap it goes from low to high. So they like segregated them and put them on their own places. And one person explained it to me like this. He said that it's a way of the system architecture making sure that it doesn't stumble over itself and it doesn't, mix up the stack and heap allocated memory in the same address. So it makes it less prone to errors and stuff like that. Uh,
So
anyways, but ever
one,
since
one,
he
one,
told me that, I was,
one grows from small to high, the other from high to small. This is what you said, right?
yeah,
Yeah,
and
but
there's this
yeah, but
empty space.
yeah, but that's what I'm saying. So just imagine that you have a, I don't know, a football field, and each of us are at one end, and the target is to meet each other. We go one, we
Yeah,
go we get close to each other, but we go at different speeds, and the goal is just to meet each
yeah,
other. We don't need to meet at the 50 meter line or something. It doesn't matter where we meet. We just need to meet. Or I don't know. We go with the car, each of us with a car from two cities, and we want to meet. But we don't go. We don't control the speed. Maybe some has traffic, go less. Other go faster. So we just want to meet, no matter where. So then we just
yeah,
go and everybody do what they can, like the memory grows and stuff. And when we meet, it's good. The same is with this. So if you if you start
yeah, yeah,
one at one
yeah,
end and the other end, you never stumble on each other just when you actually consume the whole memory, which is then okay problematic because you cannot use more because there is no more. And of course then
yeah,
it's like if you iterate on an array, one it's a normal
yeah,
iterator and the other one is a back iterator. So yeah, it grows in offset. One grows, one decreases, one increases, one decreases. So it's like obvious.
mm, yeah, yeah. Uh, yeah, but yeah, and ever since I saw that, I was like kind of interested in. Hey, I thought because you might be like something like garbage collection. Is this how it works? And a person mentioned garbage collectors in that conversation, and I also saw that on your blog that you say you worked with a guy that built a garbage collector for Java or something,
Yeah,
and I was planning to
he was
ask you about
he was fuck,
garbage collectors.
he was fucking genius. So I haven't touched that code. So he's actually he's a genius. So he's extremely intelligent, and everybody
Yeah,
fought the same. And uh, I mean those kind of stuff. I don't know. There are teams normally working, and are the guru programmers, the very good of them, and he did it alone. As he said.
yeah.
And the garbage collector, of course, it makes use of such concepts, but I mean, this particular concept is not related directly to garbage collector. So I mean, the same,
Yeah,
it's done in
yeah,
like you see Rust that it doesn't use a garbage collector. It's just how I think actually this is also how the operating system allocates. You just tell it allocate it, and
yeah,
it allocates like this, and makes sense. Yeah. But
yeah,
with the Rust, what I see, for example, is so Rust doesn't have a garbage collector. I mean, of course, but the idea at runtime, but somehow, if you think about it a little bit, is while you are running Rust code, it's a bit similar, like you would run, like you would write the code for a for a garbage collector, because you have these smart pointers, you have these the smart pointers, the reference count and stuff like that. So the idea is that if you would to implement a garbage collector from scratch, most likely you will end up having these structures. Reference count for sure you will have. So like an RC or ARC, definitely you'll have that because that's the core of, let's say, in Java or stuff like that. That when you pass a variable to a function and stuff, they just increase the reference and then it decreases, and when it's zero, okay, it's marked for cleaning. And
yeah,
it's like actually, so if you were to implement, let's say, okay, now you have it in standard library, but if you were to implement a garbage collector, you'll end up with this structure. So now you are actually using Rust is like working in a garbage collector actually, which is pretty nice. And actually it has a garbage collector but at compile time, because given how it enforces those rules, those three rules with ownership, borrowing, and lifetimes, it's actually the same. Most likely, you will end up having something similar if you write your own garbage collector. Just that it does it
yeah,
at compile time, which is actually very nice because it doesn't sacrifice the performance at runtime.
yeah,
And
yeah,
exactly that's why are these concepts which are a bit, let's say, specific to Rust. At least for me, I haven't seen this kind of how lifetimes are in Rust in other languages. Because okay, you don't need them because the garbage collector does this for you. Let's say because the garbage
yeah,
collector does stuff like this. I mean, making sure. I mean, the garbage collector does stuff like this in runtime to decide when it's safe to clear the variable from memory. But compiler, okay, fails your compilation because it doesn't allow you to write code because it doesn't have like a adaptive mechanism at runtime like what a garbage collector it is. It needs to do it performantly at compile time. And the idea is that if you do it like this, most likely you end up with a more performant code than a garbage collector, because with the garbage collector you need to be adaptive. It's like when creating a bit of generic code that can handle various situations. But if you create a code that handles a particular situation, you could optimize it for that. So it for sure is more performant.
yeah,
And
yeah,
that's why I think having like Rust did, it's way performant. And also it has for example, many big companies like Cloudflare, Discord actually switch their web services, or many of them, from Go to Rust, because, for example, Cloudflare switched their egress service, like a proxy, reverse proxy for HTTP. The idea was that they experience, so garbage collector, you don't know when it will actually run. It's unpredictable because it depends a lot of the type of request that you have, which is dynamic based on what clients send, uh, in what memory it's allocated and stuff. So you cannot predict that. So you don't know when exactly the garbage collector will run, and when it will run, there are situations where it impacts the performance of your program. And there are, in Java, I think, but everywhere, I think it's called, there are situations when it needs to stop all the threads so that it can finish some parts of the cleaning, and that is called stop the world. In that situation, actually, your program doesn't do anything. It's actually freeze,
yeah,
it's frozen. And in those situations, you cannot actually process requests, and that's bad for them, because if they have a
yeah,
burst of requests, they don't know when to scale it, and they just cannot handle the request. So That's why they needed a language without garbage collector where everything is predictable, because Rust also does these steps that the garbage collector does, because you see when you get out of scope of a method and stuff, it gets cleared, but it's more predictable and it's more granular. I mean, it's somehow you go clean. You go in the execution of your product program and you leave behind you a clean state of memory. You don't just end up accumulating garbage and then at some point, okay, fuck it, we need to stop and clean this shit. You don't have this, and
yeah,
like I said, given that the garbage collector needs to be more adaptive and dynamic, I'm sure the code is more inefficient than how Rust does it, clearing it along the way. Because then it's easier to clean because you know what you allocated. You allocate less and clean less. Then having a big chunk of garbage, then you need to know which one is reference from where and clean it. It's a mess. I mean, it's a garbage.
yeah,
It's a garbage collector.
yeah,
It's a garbage what it does. I mean, what it needs to
yeah,
do.
yeah. It also consumes a lot of time running the garbage collector.
Yeah.
Yeah, but anyways, yeah, I was just interested in that topic and those
Well,
topic like that.
I think maybe it's really a good idea to give it. I don't know if the next task, but maybe at some point. So I'll definitely put it on the list to for us to
Yeah,
build the garbage collector, because the same it will help understand, like with the search engine you see that you understood the concept of, because these are used in Elasticsearch, for example, and you see ngram and prefix tree and stuff like this are actually used there. Actually, there is where I found the first time about ngrams. I didn't know about ngrams until I used Elasticsearch, and then
yeah,
I read how they're implemented, and then yeah, it's nice. Yeah, so it's a
yeah,
very good. Thank you for suggesting it or pointing it out.
yeah,
It's a good topic.
yeah. But by the way, I was telling some of the experienced devs on the Rust Discord about this project, and uh, what they were amazed by wasn't the fact that I was able to implement it or anything like that, but they were really amazed by how the project was laid out and how like you created that document. You had a specific problem in mind. You had a unique approach to this classical problem that is, text searching. And it's like what I noticed is people that are rather more experienced are impressed by not coding things, but by the approach you take towards these solutions, by the what you just did. Uh, yeah, so it was pretty amazing. I think it's going to be really hard building another project without having someone else like you lay out the solution, the stuff like that.
Well,
So
thanks a lot, but just to to confirm that nothing is as easy as it looks. Let's say in the end, or when someone with experience does it, it was like three iterations until I got to that form. So the first one was okay, not very far, let's say, but it was not good, not good specs. Then the second one somehow I changed it, and this friend of mine started to do it, and we noticed that some things are not very clear. And I mean, they were clear somehow in my mind, but I didn't express them clear enough, so it was not clear for him what I was referring to, or what I was thinking to. And then I said, definitely, okay, if it's not clear for him, because he's also a good developer, I said that for sure it's not clear for others too. And then I rewrote all the specs from scratch, and this is how it ended
yeah,
up in that form. So it's not
yeah,
it's not
yeah,
it's like exactly with the code. First I did it, it was a garbage, okay, not a garbage, but it was like a quick let's say specs. Then with iterations I optimize it. But
yeah,
yeah, it's
yeah,
not easy to do good technical specifications, for example, because
yeah,
first is maybe you don't have the clear picture in your mind, and while you are doing it, it becomes clearer because you need to lay it down, and then you see aspects that you never thought. And then even so, after that, what you feel obvious for you because you have those pictures in your mind and you express it in the language might not be expressive enough for others to create those pictures
yeah,
in their minds, because actually this is what the language is. It's a formal, it's a transport layer, it's okay, protocol. The layer is the air. Is the transport protocol for the images we have in our mind or animations. I don't know. This is how I think, and the other person mind. So this is how we transmit the okay
yeah,
visualization and stuff. But okay, mostly is through the language, and
yeah,
it's not obvious that I transmit given that the language is so uh, I don't know, not clear. I mean, there is no. If I would to express this in a programming language, let's say, which is more strict, then it will be easier, let's say, to transmit it to other person. But in a natural language, you see, it's not clear. It's interpretable, and also English. It's quite. You can express different ways with the same uh, in the same wording, and it's hard to transmit the exact messages exact images you have in your mind. So that's why
yeah,
it's
yeah,
hard.
exactly.
It's hard to write. And even so, this is from a technical guy to another technical guy. Just imagine with the gap when I don't know, a product owner or a project manager comes and he's not technical, and he needs to create
Yeah,
specification for someone technical. Of course, there are two layers of differences. It's
yeah,
even harder to create, let's say, such kind of requirements and to be very good. That's why I'm not worried that. Let's say very quickly AI will take our developing jobs, because what we do as developers is not only writing code, which AI, okay, let's say it could get very good at, even let's say better than us. But the problem is that the specifications from the other teams are not clear. So we need to translate all those specifications in the computer language, let's say. So actually,
yeah,
the most of the time, unfortunately, in big projects, you spend clarifying the specifications and asking more questions and asking more details and stuff like that, and they change in time. So it's actually that takes more of the time than you actually write code. And if those are not clear, no. If let's suppose you have the perfect AI that generates the perfect code, exactly like like you said it, but the project manager will not be able to express it exactly what they need, because they are bad at
yeah,
that. So that's why
yeah,
I'm
yeah,
not worried about that.
yeah, yeah. Yeah, it makes sense now that you explain it because when I was like, these are like a bunch of people that I asked, and they were complimenting the technical specifications. Then I was like, wow, this is where the magic must be. But I really didn't understand why they were complimenting it. Yeah. Right now, like when you explain it, it makes sense that
Mhm.
it was a labor of love and a bunch of efforts you put into it, and it makes sense now why people are complimenting that aspect
But
of it. You know,
where have you wrote this? Can you send me links to? I mean, I would like to read if you remember the
uh,
links or something.
it was on voice chats on
Oh,
Discord
okay.
because uh, and it was one Reddit's comment, but mostly voice chats because a lot of Rust, like experienced, like really genius people on Rust go on the Discord. And like when I tell them, hey, I just did this kind of project, and they're like, wow, that's a really nice vision you have for the project. It's like a nice approach on this, on this classical problem and stuff like that. And I was like, yeah, that is where the magic is at. It's not at coding it, but at having the vision, because that comes from the experience. And now when you tell me, it's like with two technical guys and trying to, yeah, yeah, that definitely makes sense.
Yeah, it's both, because yeah, coding is also very important, because the coding is then, let's say, from those specifications that I mean the images you have in your mind, getting it to execute also performantly and efficiently, because these are very important characteristics. I mean, you can write code. For example, Python is very good at quickly doing a prototype. but it's extremely inefficient at runtime. I mean, it's I don't know. Okay, benchmarks because it depends on a lot when you're doing benchmark, but some benchmarks say it's 100 times slower than Rust and C. So it's insanely unperformant, let's say. No, but you can, yeah, you can easily express your ideas in Python. You have a lot of libraries there, and that's why it got into the AI. But it's far
Yeah,
from the ideal tool of creating efficient programs. So programming is
yeah,
also, I think, is very important. So you need to have a taste on that. But writing specification is demanding different skills a bit. So it helps if you are a programmer, let's say, or if you have. There are people who, let's say, got into project management and stuff, and were programmers, and some were actually good programmers. I had people like this, and yeah, they write very good specifications. I mean, way better than a guy who also has, I don't know, MBA or something,
yeah,
some management stuff, that they never wrote a line of code. And you also have a lot of friction with people like those because they don't understand when you tell them that it takes longer than I anticipated and how I estimated it will take because they don't understand the fact that uh, maybe you do something new, so you don't know exactly how much it will take. Maybe there are problems appearing. Maybe there are bugs in libraries you are using. Maybe there are incompatibilities. Maybe. There are a lot of maybes that you cannot take into account when you estimate, and they don't understand that how because it's not like okay, it's pretty technical and like a math, let's say, programming, but it's not 100% obvious science, let's say. So it is also the creation factor. It's very
yeah,
important how you feel, So I mean, emotionally and you are affected by that, I know you have a bad day, you have a rough period in
yeah,
your life. It affects your mind, so you don't think as straight as performant as
yeah,
in normal days. So it varies. Even for you personally, it varies a lot.
yeah,
But it's,
yeah,
it's, it's
yeah,
nice.
definitely.
It's nice also to, I don't know, to write technical uh, requirements because it also helps you clarify, I don't know, and better understand the concept because, like I told you, so this took like three iterations to get to the state of this document, and uh,
Yeah,
it clarified a lot, from the first one because, like I told you, this friend of mine didn't understood, so it was obvious for me. Then okay, then it's not good enough. The specs are not good enough, even though I had the image in my mind, and also the image in my mind changed. So it's some at the first specification, I did some mistakes, and I envisioned some things that are actually not doesn't make sense to be. I mean, it wouldn't be a good learning experience, let's say. So not they were wrong in idea that they were
mhm,
contradicting itself, but it wouldn't benefit of a good learning experience like the purpose of this was.
yeah, yeah, definitely. It's not only from the perspective of like creating the technical document, but also the approach that the you took or the problem that you identified. It was like kind of unique because I was trying to like search for other people that did search engines in Rust, and most of them is just fuzzy finding, and I feel like whenever you deal like with a problem in coding, it's like this is just where my intuition is at. Like, feel free to correct me. Uh, but let's say if I'm even building a compiler or anything, any stuff like that, it's just a matter of time before I get it right. And I feel where actually the magic happens is in identifying a problem and in creating something that you would actually want to use, you know. Even in that process of like creating the vision, I feel like you learn. Let's say if I'm making something like unique, like type of compiler or whatever, I would feel like I would learn a lot more about compilers than just going ahead and just implementing one, like finding a unique solution. And
Yeah,
uh, like that's something that I've come to appreciate a lot more. That's why even at the beginning I told you, hey, have you seen these crates? Because I was just trying to see some unique approaches, like unique solutions people came up with.
Yeah,
And
and I'm sure in that case they have they need to have something unique because to have such performance for the divide one, you mean, right? With the divide.
yeah,
I
yeah,
mean, in order to have such performance or okay, uh, ask I mean get to something like that. Of course, you need to be using something very unique because obviously others are not having such performance. And yeah, I fully agree. So it's more interesting than I don't know. You can, for example, learn I don't know algorithms or data structure. You can just learn the classical algorithm and data structure, but it's boring. Let's say you just read there. Okay, you just okay you understand them, but maybe you don't see the practical usage of this. And it's 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 a way better experience if you need to implement a problem, and even more if it's a real life problem and it's like let's say a kind of problem that you have. So, for example, you are developing an application for your uses, for what you would use, and then you discover the solutions while building it, and you discover this algorithm actually helps me a lot if I do it this algorithm and I don't know, not the other one. So actually you get to compare algorithms, like for example when they teach us at university sorting algorithms, it was like a mess. They just presented like I don't know 10 sorting algorithms. They rush it. They just give it like that, and it was like bullshit. I didn't understand the importance of all of them. But then when you end up having problems, and then you see, okay, look, this sorting algorithm is good in this situation. I mean, why use merge sort and not quick sort? If let's say quick sort is the best, but there is no best, sorting algorithm because it depends on the data. So there are cases
yeah,
where the data is such in such a way or is such so big or the hardware you are running in it's different, then one algorithm makes more sense than the other. You know,
yeah,
for example,
yeah,
the merge sort has the characteristic that all the time it has the same time complexity, all the time. And the quick sort varies based on the data. So it can vary from n log n to n squared, which is a lot. So depending on the
yeah,
data structure. So if you want a predictable time execution for a sorting algorithm, you definitely don't go with quicksort. And why, for example, is important? And in encryption, for example, that I'm having that project, it's something that is called timing attack. What this is uh, an attacker could, let's say, if you have like a branch in your code, like an if, and on one branch it takes considerably less time to execute than on the other one, then based on how much time it takes to execute some operation, the attacker can deduce where the program goes into your, I mean, where the flows goes into your code, and based on that, like it's an if, it can deduce the value that you have in the condition. you know so in encryption it's critical to have algorithms and primitives that are constant time. This is how it's called, constant time. I mean, no matter what data you feed it, it will execute in the same time. So for that,
yeah,
for example, there, if you need to do a very small search, a very small sort or something like that, I don't know. If you do a sort, definitely you will use merge sort between merge sort and quicksort, because quicksort uh, leaks some information about the data. Even if it doesn't leak the exact value, it leaks that, I don't know, it has some characteristic that it took longer, this had took shorter. It can isolate, for example, like you have a value from, I don't know, 1 to 100. It can isolate it maybe in the interval 1 to 10, and it can do brute force only between values 1 to 10. And it's a lot.
yeah,
If it reduces,
yeah,
actually, this is how Enigma machine was. I mean, also particularity like this, it helps breaking the Enigma machine, because there was some characteristic, and it reduced the space of values that they need to search. And I mean, classically, they could hack the key like in 3 days, but they change the keys daily, so it's useless. If you see the message after 3 days, it already happened because they were communicating like attack location. So it's like having the newsletter 3 days after it happens, or the daily report 3 days after it rained. what does it help you? So and
yeah,
with that, the idea was that they reduced the time to about, I don't know, 1 point something days, and based on that they were very close to the 1 day, and then they found another vulnerability which reduced it to, I don't know, 0.8 or something like that. So they were in the space, in the time that it makes sense, and it helped them to, if they can break the messages.
yeah,
So it
yeah,
there, for example, it matters a lot which
yeah,
algorithm you are using.
yeah, 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 definitely. Oh, yeah, that seems
And
like a
what
very
what
fascinating.
what I feel that it's, at least from my personal experience, and I think it's obvious for everybody. Uh, the best way to learn a language is picking up a project and building a project of something that you like, and of something that you like use. I mean, make an application that you like using. And then at the end, you can also end up with an application that you will use. Maybe okay, maybe it's hard to do it like the level of other applications, but you are more motivated to do it because it's something that you like, and you will have, let's say, like you said, unique ways of fixing, implementing something. You will have more specific and clearer, let's say, requirements, because you build the requirements when you're doing your application, so you know better how the application should behave because you know your problem, and this is resolving your problem. So like, I don't know, I have a friend that, she has diabetes, and she's a UI UX, the designer, and she's thinking of building an application, for people with diabetes. And she tried a lot of application, but all they have like some problems. And I think she's the best candidate, to build such a UI and a specification UI, for such an application, because she knows already the problems that the customers, that the clients will using are facing. And she
Yeah,
she experienced on her own skin, so it's very important. I mean, to resolve
yeah,
your problem. So that's why I recommend to everyone who's learning a new language, pick some project that you think is very interesting, even to be, like you said, like a compiler, like a garbage collector. Pick something like this and just build it. And you learn in time.
yeah,
You iterate through it. It's not a problem. It doesn't. And see it as a learning project. It doesn't need to be perfect. That's not the point. It's for learning. But
yeah,
then in the
yeah,
end, you could end up, I don't know, having a nice. For example, this is how it started for me with the encryption file system. I
yeah,
It was like trying to resolve also for me. At some point, it helped me to have like a solution to be able to create encrypted folders. Then I could then sync with other application. And I said, this is a nice idea, or this is a nice project that I could build, even if I don't use this. But at least it is something that I feel like using it. And it motivates me more to be like that. Plus, it's
yeah,
more interesting, like you said, that you are curious how it works, like a garbage collector or a compiler. This kind of curiosity motivates you to learn more, about the language, not just reading the book and stuff and looking tutorials. That's don't learn only by that. Learn by doing.
yeah,
It's way more. Okay, you need to combine them because you cannot only just, okay, I start writing code, but what do you write? You ask ChatGPT. I mean, ChatGPT could tell you a lot, but how? What do you ask him? What do you ask it? you know.
yeah, 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 yeah. That's definitely true.
Yeah, so I would recommend you to build a compiler, build a garbage collector.
Yeah,
Doesn't need to be perfect.
yeah,
That's not the point.
yeah, yeah,
Iterate, and
yeah,
actually
definitely.
is nice if you look in time. If you look at the code, how it evolved, and if you look at the commits, I don't know, the first commit you did and stuff like this. You look at that structure, how it looks, and the functionality, and you look how it's now, and you say, man, yeah, I really learned something.
Yeah, yeah, yeah,
You
yeah.
said, look what
That
stupid
was what
things.
I was.
Yeah, so I really recommend it.
Yeah, yeah. Oh, yeah, definitely. Oh, yeah. Oh, so, oh, yeah. That was what I was planning to. ask you about nowadays. And yeah, it's okay if we just talk over Discord and stuff like that.
Yeah, sure. Any
Uh,
communication
yeah.
is fine.
Thanks a lot, Raju. This means like a lot. Uh,
I'm very happy if you find it helpful, and yeah, thank you too, because it was really good time for me to watch this
yeah,
and participate to this discussion.
yeah, yeah. Likewise. Likewise.
So it was very great. And keep up the good work.
Okay, okay. Thank you.
Thank you also. Have a great rest of the day. I don't know exactly what time is there, but late I assume.
Yeah, yeah. Okay.
See.
Yeah. The same. Uh,
Thank you.
bye.
See you.
Bye.
Bye.
Okay.
Bye.
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 Bye.